Now, as we start to dig into the topics and look at some examples on some of the development aspects of databases, I want to briefly bring to your attention the idea of systematic database design. There's all kind of numbers out there in the real world that 70 to 75% of all projects basically die on the vine. These things just finally get killed because they're over budget, scope has creeped way out of anybody's original imaginations of how big the thing would be and how expensive it would be. And Microsoft has some documentation out there called the Microsoft Operations Framework. It's at version 4.0. Go out and look that up on Microsoft's website. But what Microsoft's really trying to stress is that you need some sort of systematic database design plan, or you're going to end up like those 75% of all the projects that are started with your database project. So what I want to do here is I don't want to spend a whole bunch of time going through this. You could spend an hour or so here. I'll just refer you to that and let you go out there and read. There are guidelines and practices for virtually every area of IT, but we're going to concentrate on the database right here. Notice first step, Microsoft says, identify and document your database requirements. Now, requirements is what gets most people. And there's all kind of books out there about how to get requirements, how to drive these things through and make sure you have what you need. I would suggest you dig into that information. Then you want to create a conceptual model. Then you want to transform that conceptual model into a logical model, and then implement a physical model from that logical model, and then you want to refine the physical model. And we're going to talk about these in a little more detail here. And then we'll finally build a prototype and actually test our database design. To identify and document the database requirements, it's going to take some research, and then you're going to have to formulate and document the requirements of users and customers. And you can't just say, if you go to, say, accounting and say, how do you do this, they're going to tell you their perception. Then if you go to sales and say, how do you do this, they're going to tell you something different probably than what accounting did. So you're going to have to get everybody's ideas down and formulate and document the requirements of both the customers and the users. And this is not a one-meeting thing. You'll have to go back and back a few times and make sure that you have everybody's perspective here. Then you're going to create a conceptual model. And with that, you are going to define the essential relationships and kind of the flow of how the data moves through the system based on what you have been told. Now, here's a huge key right here. The conceptual model is based on the user's perspective and the views of all the customers. If you can nail this, you can avoid a lot of those issues later where they say, no, that's not what we meant. What it needs to do is. So you're basically going to draw diagrams, flowcharts, that sort of thing, based on what the customer told you and based on what they said they wanted. And then you need to step through that with them and say, now here's, okay, an order comes in the door right here. We process it. It's a state order, so it goes over here. And just flow through it and make sure that you're kind of regurgitating back to them what they gave you and that it still makes sense to them. Then you're going to transfer. Once you get a buy-in from them on that conceptual model, you're going to turn it into a logical model, and now you're just going to redraw it in a way that makes sense to the nerds. All you database folks are going to draw this from the perspective of the development team, the people who are building the tables, operating the database, writing the code to load the databases and edit the data and so forth. And you're going to decide on, okay, what are my relationships between my tables? How much normalization do I need? When do I need to denormalize? All that sort of thing. Next step, you want to implement the physical model. So we drew it up in the conceptual the way the customer said. Then we translated that into the way that we have to think about it in a table design kind of world. And now we're actually going to start to build that physical model. You're going to now start to design your tables based on the database management system, and you'll see DBMS or RDBMS for relational database management system all over the place out there as you're reading. So what I'm really saying here is if you're using Oracle, if you're using SQL Server, and of course in our class we're using SQL Server, you're going to decide, okay, based on the functionalities and the bells and whistles of my particular environment, this is what I need to build. Now here's where I need to determine the data types that are going to be in the fields in my tables. How many tables, how they're going to be related, any physical constraints, what data will we allow, what will we not allow, are we allowing nulls, are we not allowing nulls, all those kinds of questions. Then you're going to refine the physical model. Now earlier in the course, and I can't remember which video, I talked about the fact that your second database that you design will be a good one. That is exactly what you're doing here. It'll always be that way. So we're going to take that original physical model and we're going to refine it. We're going to start to think through it again, and we're going to look for ways that we could do it better. Notice here, it is difficult to get the physical model right the first time. It just is. So we're going to start to make adjustments for performance, for security, for auditing this thing, for availability, and a big one, scalability. It's going to get larger over time. So we're going to build a prototype and actually test the database design. And you can test it just by running the stored procedures and so forth. And once you're comfortable with that, we're going to construct a prototype. We're going to test it on a very small scale. And then we're going to look for those problems that tell us what we need to correct. And once we've got that stable, then we're going to create a full test version to throw out there for application developers. And then once we get everybody happy on the nerd side, we're going to start doing beta testing with end users. This will help to ensure success, and from the big thing, especially if you're a self-employed contractor type, it lets you know when this project starts, when this project ends, and when I have told you, when I've completed what I told you I would do, and that I give you the functionality that you want. I strongly recommend go out and read and dig into the Microsoft Operations Framework and make sure you use a systematic database design plan.